Problem A describes the following process. We start in point 0, 0, and we make moves north, south, west or east. First move is by 1 unit, second by 2 units, then 4, 8, 16 and so on, every next power of 2. Here we would be at point 0, 1, 2, 1 and finally 2, 5, because the last move was by 4 units. Given the final destination, like 2, 5, print any sequence of moves that would reach that destination, like here for 2, 5 we could print north, east, north. In problem C, there is a sequence of cards in order like the one you see on the screen right now. There are ranks and colors, and first there's everything of color A, then everything of color B, and so on. Each color is sorted increasingly by rank. What you can do every time in every move is to take some substring, some interval of those, and put that at the beginning of a sequence. Here now the beginning would be 3A, 4A, and so on. So like that, this is a new sequence. And our goal is to make cards sorted by number. So at the end, no matter the colors, but the sequence must look like 1, 1, 1 here, 2, 2, 2, 3, 3, 3, 4, 4, 4, and it doesn't matter what colors will be here. We need to achieve the minimum possible number of moves. Print any sequence with minimum possible length. My first idea, or my first hope, was that I can just take some interval and move it to the beginning so that two numbers would now equal to each other would now be together. If I move this 1, 2, 3 at the beginning, new sequence is 1, 2, 3, then 1, 2, 3, 4. I'm just now rewriting this 1, 2, 3, 4, and now 4 again. Those two 4s are now here. Then in similar way I can move this to the beginning, and after such two moves, all 4s are next to each other. And I would just continue that 4, 4, 4. The number of moves I need is around just the size of the sequence, minus the number of ones. Ones at the end will automatically become the same, next to each other. Like if you had 1, 2, 1, 2, now you moved this 1 to the beginning, you already have 1, 1, 2, 2. Ones are handled automatically. Then I coded that and it will turn out incorrect, sadly. So this means that apparently one can do fewer moves and achieve the goal. After failing to find a solution for C, or at least understanding why my naive solution is incorrect, I couldn't on a piece of paper find a better sequence of moves. I decided to write an exponential solution, a brute force, that would print some optimal sequences of moves for bigger tests, and this way I could analyze that and maybe see a pattern, or at least get some idea for a solution. I indeed find some pattern in optimal moves printed by a brute force. Not only it just moves some interval to the beginning, but it tries to, after this is moved, it tries to help not only those two forces to make them next to each other, but also this position. If instead of this 1, 2, 3, I moved, for example, let's say this 3, 4, 1, not only those twos would be next to each other, but also this one would be next to this one. It would be 3, 4, 1, then 1 again, I'm rewriting for that, 1, 2, 3, 4, 1, 2, 2, 3, 4. So I make those two next to each other and those two. I'm almost twice as fast. And it's strange to say move this interval from to the beginning, because this is okay, and turns out that it leads to something optimal. What I did later in code is I tried to find first such interval. So when I'm seeing that at the beginning of the sequence there is 1, I try to move some interval that will end with a 1 here. So this is the next one. Looking from that to the left, I try to find such an interval that this 2 will be next to another 2. So this should be next to this thing. So going from, the logic will be, check what number is at the first position, find next occurrence of this number, and now going from this number to the left, find the next occurrence of this number after you. And now if you move this to the beginning, you will get two new numbers to be next to each other and equal to each other. It will be now 3, 4, 1, 1, 2, 2, 3, and so on. And it's magic for me why this will give us an optimal solution. But just the intuition is that you want to make same numbers to be next to each other. And it turns out that it is possible with some small if I needed to add for odd n or even n later. You can see now on the screen that one of my asserts fails sometimes when the sequence is almost sorted. I'm just one move away from sorting because all big numbers are at the beginning, and just I need to move everything after that to the front. One last move, and I need a fix for that. By the way, this is why asserts are useful. It would normally be hard for me to see from a sequence of moves that it isn't good. Because how a human would decide that moves like 3-5, 2-4, 5-6 and so on, they do not lead to a correct solution. This is why you should put asserts and then realize that there is a mistake, so fix it. My solution for A is overcomplicated, but the idea is to look at bits from the end and then decide, well, if I see a 1 here, then for sure I need to change it by moving in such a direction that x will change by 1 down or up. But if I say here +1, so if I need, let's say, make a move east, it increases x. Oh, by the way, I try to get from xy to 0, 0. And at the end I will need to flip all the north, south, west, east things in the output. Yeah, if I do +1 here, then I will get carried +1 to the left. My solution is to decide moves from right to left and do dp of, well, 30, there are at most 31 or 32 bits, just to make sure. I think I did 33 in my code, and then 2, 2. And those two states, they tell me if I need to carry 1 in number x and if I need to carry 1 in number y. At the end, if I don't carry anything and I'm like done with both strings, then I can print that. So this was for me string. dp hold either like information impossible, I think for me it was string x, or otherwise a sequence of moves. Plus I used some tricks not to handle negative x. I had a boolean value, so if x was -5, then I forgot about this minus, but I held boolean flag x negative. At the end I will flip all the moves related to x, so from west to south, from west to east, and from east to west. But in the editorial and in Codeforce's discussion for the contest, you will find much simpler solution for this problem. dp was not needed. A is a problem where it's very easy to test the solution on a few small tests, other than sample tests, and it helped me to avoid the wrong submission. For test 02, I got information. My program thought that single move north is enough to get the answer. Instead, it should be impossible. First move north, it will move you by 1, not by 2. And then I analyzed my code and printed some debug information for quite some time, only then to find an unusual bug. Like I just did something incorrectly in C++. You cannot iterate over characters of a string just by typing for character C in, and now in literal quotes, NSWE. Instead, because this is treated as, I think, as a character array, and there is 0 character at the end. So like, next was none of those 4 characters from time to time. Instead, I needed to change that to standard iteration over array with 4 characters. So just one tiny detail, but testing helped. So try to remember about that, and also test your program a little bit before submitting from time to time. Problem B is interactive and maybe my favorite in this contest, even though it wasn't that interesting. In a big square with coordinates -billion +billion, there is a circle of quite big radius, so it's not that it's very small and hard to find, and you can ask queries, ask about a single point, and you will get information if it's outside or inside the circle, or maybe exactly the center. Your goal is to find the center of a circle. You don't know a radius at the beginning. And my very first idea was to because the circle is big, is to get random points, ask anywhere in a square till we get a point inside the circle. Then it's a start. At the end, I decided not to get random points, instead to iterate with a quite regular grid, because for sure I will hit the circle as well, and I just wanted to avoid a random function if possible. Then, it's easier to predict what your program will do and to understand if there are any bugs. But what then? Think about it for a moment yourself. Then, starting from this point, we can binary search to above and below. Binary search is very common in interactive problem, and we can find the last point inside the circle, and here the last point inside the circle. What is cool about it is that the middle of this will give you a horizontal line passing through the center of a circle. So now you know one coordinate of a center. Center is somewhere here. But you can do the same looking right and left. Again, binary search, the last point here that is still inside the circle, same here. Then take the middle of those two, and you get this line also passing through the circle. So the middle of x coordinate of this point and this one, the middle of that will give you x coordinate of the center. Just remember while implementing to stop whenever you get answer center. Maybe by coincidence you will get center of a circle, and then you should stop this test case. The total number of queries will be log of coordinates times 4. Because you do 4 binary searches, plus the number of queries first to ask about that regular grid or random points, but it will be around 50, 100, something like that. Sound is back. I don't think I did well, because I spent a lot of time on the last problem, thinking about it, and also the first problem, I couldn't solve it very fast. People in the top, I see they spent like 25 minutes on the last one. I spent an hour or so. But I think at least interactive was quick. Where am I here? Interactive took me, 12 minutes? I think it should be one of the best times. And it was, I didn't read it before, so before finishing this one, so it's really 12 minutes. I see a pattern in qualification round, it was the same. Interactive was easy for me, so I just hope to have some hard interactive problem in the real rounds, like the third one, to decide about passing. Right now I have 29th place. Do I have wrong submissions? I have one. In 4 minutes it will be obvious what place I have. I'm over here. 1:32. Well, I wasn't that far away from the top. Top time is hour and 4 minutes. I have hour and 32. There is 1 hour remaining till the end. I can now maybe add some extra commentary, but then maybe I should prepare drawings first for that. I don't know why this solution is correct, what I wrote. I just wrote brute force to check a pattern and then implemented greedy that would match that. I don't know. This is some DP, but maybe it can be done more greedily. And this is a nice interactive problem. Maybe I will get back here in a moment. Should I add commentary during the video? Maybe. Okay, I will do something in a moment. Bye-bye for now. And after the contest, I realized that my submission for B failed, the big test. It's the interactive problem. And I very quickly understood what's the reason. I wanted to do binary search starting from the found point, going in each of 4 directions. But what I did is I just binary searched from -billion to billion. You cannot do something like that. In big intervals, find shorter interval that is inside something with binary search, because you might never hit that interval. Instead, you will quickly fix that here. First inside, blah, 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 low and high. I need to fix this interval to just be from something to something. What about this? If, can I modify that? I can't, but maybe I can copy this, paste here. C++ is chosen. This will be a hack. If low is -m and high is m, so if it's the first repetition, then mid will be that value x or y, like from -billion to billion. I first want to hit exactly in this circle, so from now on it will be a reasonable interval. What is that? First last repetition. If repetition is 0, then x2 is middle, and I'm searching for y, like that, right? If rep is 0, then I'm looking for x. No. Yeah, then I'm looking for y, because here I'm fixing x2. Cool, else mid is x. I hope this works. No, I didn't check before. For sure I was very close to doing it correctly. I thought about it during the contest. I don't know why after a moment, while implementing, I didn't remember to that. Also, a lesson for me is to test more, even after I submit the problem, if there are any hidden tests, like here in this interactive problem. It makes sense that it was something random. Okay, this is wrong. Why? No, if repeat is 0, then you're looking for x, because the other is fixed. So this is x, this is y. Just this must match that. Repeat equal to 0. It means I'm looking for the value of x. Still waiting. And accepted. This was a difference from incorrect code and the correct one. It's a pity that smaller tests didn't catch that, but indeed in smaller tests the circle is quite big, so something is impossible. Doesn't matter too much. Cool, I hope you learned something from this screencast. I think for the next round I will not spend that much time on editing. This is how right now my editing project looks like. If you see here you can see a lot of like extra commentary, titles. It took me a lot of time to edit this, and instead I should spend time on, for example, making lectures or videos about some problems, not this. Or maybe you have some other ideas. If yes, tell me in the comments below. Like a video if you indeed liked it, and see you next time. Bye bye.